We use it pretty much every single day. But have you ever just stopped and wondered how it actually works? I'm talking about GPS, of course. Today we're going to pull back the curtain on the incredible science behind that tiny blue dot on your map. You know the feeling. You pull out your phone, pop open a map, and there it is, that little blinking blue dot that tells you exactly where you're standing. It honestly feels like magic. But how on earth does your phone, this little device in your hand, pinpoint your location on a planet that's 40,000 kilometers around? Well, that's the mystery we are solving today. To really understand the magic, we have to start with the dot itself. What is it actually representing?
That dot? That's your position, and it's calculated by the Global Positioning System, or GPS. It's this huge, invisible network of satellites that can figure out your location, your speed, and the precise time anywhere on the planet, just as long as you can see the sky.
Now that word global is the first big clue, and it points us to the absolute heart of the system, a whole network of satellites that basically act like super precise clocks way up in the sky.
And we're not just talking about a couple of them. This is a whole constellation of over 30 satellites, all orbiting about 20,000 kilometers above our heads. This massive setup makes sure that no matter where you are on the globe, your phone can always see at least 4 of them at any given time.
And what's really fascinating is how simple their job is. These satellites, they aren't looking down at you. Just think of them as lighthouses in space. They're constantly broadcasting a simple radio signal that contains just 2 key pieces of information. First, their exact position in space, and second, the exact time the message was sent, all thanks to these incredibly accurate atomic clocks they have on board.
Okay, so your phone gets this signal with a timestamp. How in the world does that turn into a location? Well, it all comes down to a fundamental law of physics.
Your phone does this beautifully simple calculation. It just looks at the time the satellite sent the signal, checks its own clock the moment it arrives, and figures out the tiny, tiny delay. And since radio waves travel at the speed of light, a constant, it just multiplies that travel time by the speed of light. And voila, it knows the exact distance to that satellite.
But knowing you're, let's say, 21,000 kilometers away from one satellite, that's not a location, right? It's just a distance. Now your phone has to become a master geometer and solve this amazing space puzzle.
And the method it uses is called trilateration. This is the key. You might have heard of triangulation, which uses angles. This is different. Trilateration uses known distances from known points, in our case the satellites, to find a precise position.
So with the distance from just one satellite, your phone only knows you're somewhere on the surface of a giant sphere, with that satellite right at the center. It's a start, but it's not super helpful.
But then, your phone picks up a signal from a second satellite. Now those 2 giant spheres of possibility intersect, and that narrows your possible location down to a perfect circle. See, we're getting so much closer.
Now add a third satellite. That circle gets crunched down to just 2 possible points. And usually one of them is kind of ridiculous, like it's in deep space or moving at an impossible speed, so your phone can often guess which one is you. But to be absolutely certain and to solve one final hidden problem, we need a fourth.
So what is this hidden problem? Why aren't 3 satellites enough to get it perfect? Well, the problem isn't out there in space. It's actually right there in your hand. The whole issue is time. Those atomic clocks on the satellites are accurate to the nanosecond. It's just mind-boggling. Your phone's clock is, well, it's good, but it's not that good. In fact, the satellite clocks are so sensitive that engineers have to constantly correct them for Einstein's theories of relativity. Because they're moving so fast and they're in a weaker gravitational field, their clocks literally run a tiny bit faster than ours on Earth. Without that correction, GPS would be off by kilometers every single day. So even a microsecond error in your phone's clock, when you multiply by the speed of light, can throw your position off by hundreds of meters. And this is where that 4th satellite becomes the hero of the story. It provides just enough information for your phone to solve for 4 things at once: your 3 position coordinates, X, Y, and Z, and that 4th unknown, its own clock error. That 4th signal lets your phone perfectly sync its time with the whole satellite system, locking in your one true location. So, that's the theory in a perfect world. But, the real world is messy. Those signals have to travel through our atmosphere and bounce around our cities, and that can definitely cause some problems.
For instance, a GPS signal can get slowed down just a little bit as it passes through the atmosphere. Or it can bounce off a tall building. That's called multipath error, making the path seem longer than it really was. And of course, those tiny clock errors are always a factor that has to be managed.
But for every problem, there's a really clever fix. Your phone uses something called Assisted GPS, or AGPS, which gets a rough location from cell towers to help it find the satellites way faster. And for things like aviation that need extreme precision, there are even more advanced systems that use ground stations to send out corrections in real time.
And with that kind of amazing accuracy, GPS has become way more than just a map on our phones. It's really this invisible utility that silently powers our entire modern world.
I mean, just think about it. It guides our planes and our ships. It helps farmers with precision agriculture to feed the planet. It tracks global shipping fleets. It helps coordinate emergency services. From the app you use to get a ride home to the entire global supply chain, our modern economy truly runs on this network of clocks in the sky.
And after all those calculations, all the corrections, and all that complex physics, the system delivers that little blue dot to your screen with an everyday accuracy of about 5 to 10 meters. It is an absolutely incredible feat of engineering that we all get to carry around in our pockets.
So if you take away just one thing from all of this, let it be this mental model. GPS is not really a positioning system. At its heart, it is a fantastically precise, space-based timing system. Your phone is just a very clever receiver that uses that timing data to solve a geometry puzzle in real time.
This system gave us a map of ourselves, letting us see where we are on the planet with a precision that was once thought impossible. It's completely changed our relationship with the world around us. So it leaves you with a final thought. What will a system like this allow us to map next?